So for question 2, the table below gives the composition of 6 particles which are either atoms or ions. So particle A until F were given here, and the number of protons, number of neutrons, and number of electrons for each and every particle were given. Question A, which particles are atoms? Now we know by definition, atoms have the same number of protons and electrons because they are electrically neutral. That's actually the explanation that we can actually give here. And looking at all the given particles here, so particle A has 33 protons and 33 electrons as well. Same with particle D, it has 33 protons and 33 electrons, and same with letter E, it has 13 protons and 13 electrons. So for this question, the particles that are atoms are A, D, and E. And again, explain your choice. As I have said, they have the same number of protons and electrons, or they are electrically neutral. You better write that down in your answers later on. Now for letter B, which particle is a negative ion and has this particle got a negative charge? Okay, looking at again all the given particles. So by definition, an ion who got a negative charge is a negative ion. And when we say an ion is negative, there are more electrons than protons. Or we can say as well that it has gained electrons. So, so we have A, B, C, D, E, and F. I would say the answer here will be letter C, so element C. Why is that? Because there are 34 protons for particle C, I should say, and there are 36 electrons compared to the other particles given. Okay, compared to the given other particles given. So we can say the particle particle C. All right, particle C, and since it is, yeah, I think that's it. That's enough. Which and why it was asked why, so we need to reason out. Sorry. So we have because it has more electrons than protons. All right, or you can also say that it has gained electrons. Why not? Now for letter C, which particles are positive ions? Since letter B is like an opposite of letter C, wherein it's all about positive ion or cations. So positive ions has more protons than electrons. And in here, we see that particle B has 19 protons and 18 electrons, and particle F has 14 protons and 21 electrons. So meaning for letter C, the particles which are positive ions will be particles B and F. Now for letter D, explain why particle A and D are isotopes. Now by definition, we know that isotopes are elements which have the same number of protons, but they have different number of neutrons or neutron number. And again, looking back at the table, we can say that particle A has 33 protons and 33 electrons, and the its neutrons is 40. And same with particle B, it's not, they have different. Particle D has the same number of protons and electrons, but the number of neutrons is 42. And I think that's it. We have A and B only for this question. So they are isotopes. That's why they are isotopes. Again, by definition, isotopes have the same number of protons but have different number of neutrons of neutron number. Please remember as well that the definition of an isotope is key into identifying which particles fit this definition. Saying how the particles fit this definition is a good explanation for this type of question. Okay, so maybe we can just write it down here. They have the same number of protons, the same number of protons. Okay, and another reason is that they have different number of neutrons. Maybe you can just bullet it. Why not? They have different number of neutrons. Alright, so those two reasons will do for these two marks.